All right, today's lesson 80, and this is a wonderful algebraic lesson. So the first half is something you've done before. Second half is something that you will run into a lot more as you continue progressing here, but probably haven't really dealt with it yet. So two-part lesson. The first thing is adding and subtracting mixed measurements. In other words, as you can see, like minutes and seconds, if you have 5 minutes and 30 seconds and you subtract something from it, what is it? The second half is polynomials, which is poly means many, nomial is a term that we're going to run into. So start with the first thing. I'm not going to tell you necessarily how to do it because you should know how to do it. Example one, we're going to jump right into it, and it is a measurement of Regina's triathlon. She swam, she biked, and she ran. She wants to know, so if you know that she swam for 27 minutes, 50 seconds, she, I think that's wrong. Yeah, and then she biked for 48 minutes and 28 seconds, and then she ran for 42 minutes and 53 seconds. What was the total time that she spent? Well, it's adding, so yeah, you just add just like you would here. So 15 plus 28 plus 53 gives you an answer of 96 seconds. And then how many minutes was it total? If you add 27 and 48 and 42 together, you get 117 minutes. Now, you might be like, all right, she ran for 117 minutes and 96 seconds. Well, there's a problem because you can pull a minute out of here. How many seconds are in a minute? There's 60. So if you pull a 60 out here, 60 seconds is equal to 1 minute, you're left with 36 seconds. So you can pull 1 minute out and say 118 minutes and 36 seconds. So it's basic addition, subtraction, but you have to make sure that you don't have an excess number. If you could pull a minute out, you want to get the biggest term. So if there was an hour after here, you would pull these minutes out and actually write an hour as well. But all you have is minutes and seconds. And you don't say 117 minutes and 96 seconds because you know that there's only 60 seconds in a minute. So you would say 118 minutes and 36 seconds. Second example there is Junior, I think is what his name is. When he was born, he weighed 7 pounds and 12 ounces. How old was he? Now he weighs 12 pounds and 5 ounces. How much did he grow? How much weight did Junior put on? Well, you subtract there. You run into a problem immediately because 5 divided by 12 does not work. So you have to pull over from the 12. So you change the 12 to an 11. And what do? Do you just add, change 5 to 6, just add 1? No, because how many ounces are in a pound? That's the question you have to ask. And you actually pull it over, and there are 16 ounces in 1 pound. So you pull 1 pound over because you subtract, or you take 1 away from here. So you're pulling 16 ounces over, or 1 pound. And so you go 16 plus 5, because you already have 5 here. 16 plus 5 is 21. 21 minus 12 then gives you an answer of 9 ounces. And how many pounds do you have over here? 11 pounds minus 7 pounds. Your answer is 4 pounds, 9 ounces is what you would get there, right? So sometimes you have to carry over, sometimes you don't. But just be careful that you pull the right number over. That's how it works there. All right, so then example 3 here, a little bit variation. Here, Marisa, last year it was a physical fitness test, and she ran a mile in 12 minutes and 15 seconds. This year, same thing, and she improved her time and ran it in 9 minutes and 48 seconds. How much did she improve? Well, again, 15 minus 48, you can't do it. So how do we figure that out? Take this, change it to 11, and now you have how many seconds do you add to this? Well, how many seconds are 1 minute? Because that's what you took away. It's 60, so 60 plus 15 is 75. Now you can subtract 75 minus 48, 27 seconds. And how many minutes are left? 11 minus 9 is 2. So she ran at 2 minutes and 27 seconds faster there. And that is what is in the book. So again, you just have to make sure that you can do it, and you have to make sure that you are pulling over the right amount. Sure, it's 1 minute, but you're changing it to seconds, so you have to go 60 rather than just 1. All right, so that's that. Fairly basic concept there. And you know what? I'm actually going to pause this, and we're going to do the practice set that involves that. All right, we're back and have some different information here. So practice set of adding and subtracting mixed measures here. So practice set A here. You have 3 hours, 32 minutes, 45 seconds, 1 hour, 42 minutes, 27 seconds. Adding them together. So I'm just going to run through it. We're going to figure this out. 2, 6, 72 seconds is what we have. What you could do already, depends how you want to do it. You can already, you look at this and say, okay, we're going to have some left over. So you could subtract 60 seconds a while, and that leaves you with 12 seconds. And you could take that number, because you're pulling 1 minute out, add it to here. So 32 plus 1 is 33. 33 plus 43 is 76. 76 minutes. Well, you could look at that and say, well, I already have it. Because I'm moving to hours. So 1 hour is 60 minutes. So again, I'm subtracting 60 from here. And that leaves 76 is 16 minutes. And it took an hour out. So you add it to here. 3 plus 4 plus 1. 3 plus 1 plus 1 is 5. So that gives you 5 hours, 60 minutes, and 12 seconds there. It's up to you. If you want to just figure out all these things and then carry them over, it'll get the same answer. But if you want to save yourself from getting it and then going back and figuring it out, you can do it that way. All right, B then, you have 5 pounds, 8 ounces, plus 8 pounds, 9 ounces. 9 plus 8 is 17 ounces. How many ounces are in a pound? 16. Subtract that right away. Gives you 1 ounce, and add a pound over here. 8 plus 6 is 14 pounds, and 1 ounce is the answer you would get for that. For C, then, you have, it's actually a rectangle here, the problem that they give you, and he needs to buy something to go the entire way around it. So, how do you figure that out? You know that the perimeter of a rectangle is 2 times the length, right here, 2 of these, plus 2 times the width, so 2 of these. So you add them together. 10 plus 10 plus 20 plus 8 is 28 inches. And you're changing that to feet. So you know that how many feet can you pull out of 28? Well, 1 foot is 12 inches, so therefore you can get 2 of them, because that's 24. So 28 minus 24 leaves you with 4 inches. Now make sure that you put a 2 up here, because you pulled 2 feet out, not just 1, but 2. And then you add these together. 24 plus 20 is 44. Let me just make sure I do this right. 6, and then 1, 2, 3, 4. 46 feet and 4 inches. That's the correct answer there. Now, there is a possibility that I'm doing these wrong. I'm not checking the answers. I'm just doing them and assuming that I haven't done correctly. So if you catch it, good job for you. I probably quick check that here. All right, then D, E, and F are subtraction problems. So D, you have those 2 measurements I need to subtract. So the first thing is 12 minus 30 doesn't work, so you change the minutes to 14. You add 1 minute is 60 seconds, so 60 plus 12 is 72. 72 minus 30 is, what am I doing? 72 minus 30 is 42 seconds. All right, now you have 14 minus 42. Again, it doesn't work, so you have to pull from the hours. How many minutes are in 1 hour? 60. So you have 74. 14 plus 60 is 74. Subtract that, you have 32. 32 minutes, and then 2 minus 1 is 1 hour. Your answer is that's right there. For E, same thing. 2 minus 7 doesn't work. Change that to 5. How many inches are in 1 foot? 12. So you have 14 minus 7 is 7 inches. 5 minus 4 feet is 1 foot, 7 inches for your answer there. For letter F, you have, he has an 8-foot long board and he's chopping a 2-foot, he's taking off 2 feet and 7 1/2 inches for that problem. So what's left with the board? Well, how many inches are here? None. So right now you have changes to 7. How many inches are in 1 foot? 12. So 12 minus 7 1/2 gets you, 12 minus 7 is 5. That's 4.5 inches and 5 feet. Just make sure I did that right. Yeah. 4.5. So 5 feet, 4.5 inches is what is left from the board there. So that is adding and subtracting mixed measurement numbers. So switching gears a little bit and jumping to polynomials. Again, it's a big word. Poly means many. Nomial is another word for terms here. So we're going to talk about 3 of them. We're going to talk about a monomial, a binomial, and a trinomial. So what's happening there is if you take the word poly out and put monomial, binomial, trinomial. And that just means mono is 1, so 1 term. Some examples are any number, any term that is referencing 1 thing. So y, that's 1 term. It's referencing either it's a variable for something or it's actually referencing that. 7, just 1 term. 2x to the 4th. It's 2 things there. It's a 2 and x to the 4th, but it's talking about 1 thing. Like if you would be talking about a car, well, you could talk about a Chevy Camaro. Sure, it's a Chevy and a Camaro, but it's still 1 thing. It's kind of what it's saying here. 2x to the 4th is, it's 1 thing, but there's different ways of describing it. And the last one is still 1 term, 5a, b, c. That would be 1 term, although it may seem like what's a bunch of things, yes, but it's still 1 thing. I mean, you'll see where that changes. Then a binomial is 2 terms. Some examples of that is you take 1 term y and -7. So y minus 7, that is 2 terms. You have y is 1 term, -7 is the other. And that is referencing 2 terms there. Then you have 2x to the 4th, that's your first term. -3x is your second term. It's 2 terms there, right? It's not talking about 1 thing, it's talking about 2 separate things. You have y and a -7, and you have 2x to the 4th minus 3x. So big clue for you all when you're like, well, how do I know the difference between if it's talking about 1 thing or if it's talking about 2 separate things? The biggest clue is there's going to be a subtraction sign or a negative sign or a positive sign before each term. So if you have, for example, for my next term here, a trinomial 3 terms, in front of the a squared is an understood positive sign, okay? So there's your first term. Look for the next positive or negative sign right here, plus c. That's your next term. So a squared is your first term, positive c is your second term, and then here's a negative sign. -5 is your last term. So the 3 terms are a squared, positive c, and -5 there. You can put them together. Now, you might be asking, well, how the next step is a degree. And that gets a little bit, I'll admit, this is a little bit confusing here. Just bear with me for a little bit. So if you look up here, the different terms, you can have an exponent. For all A, B, and C all have an understood term of one, exponent of 1. Y has an understood exponent of 1. Here you have the terms, here you have a 4 exponent, you have a 2 for an exponent. That's what the degrees are talking about. The degree of a polynomial, you have 3 examples here. Y to the first, look at the exponent. It's 1. It's to the first degree there, right? So you're going to be looking at exponents for the degrees. And another word they use for it is linear. If we're talking about just y to the first, it's just referencing one measurement, which is often in a line. Y squared, then, it's to the second degree. And so just to give you an example, if you have y, it just gives you a straight line, linear. Y to the second gives you 2 measurements. You have this way, and then you also have another way. So what do you get out of that? You start getting a shape, parallelogram, a quad, forget what the word is, but you start getting a shape out of it. Actually, you can see it starts taking shape. And then the third thing is you have y cubed. This is the third degree because the exponent is 3. It's cubic. And the reason because of that is you have this way, you have up, and then you also give it depth, right? So if you would draw that out and connect all those points, you would actually get a cube, which is why it's cubic, referring to that. Now, the tricky thing is when you have, for example, if you jump up to here, if you have 5a, b, c, what's the degree there? What degree is that of that polynomial? Because a has an understood 1, b has an understood 1, and c has an understood 1 as exponent. There's 3 of those. The way you figure that out is you take all the exponents in one term and you add them together, and that's what your degree is. So for this one, 5, a to the first, b to the first. They're both understood, you don't put the 1 in. But if you have a to the first, there's 1, b to the first, there's another 1. What degree does that polynomial have? Well, it has 1 and 1. You add them together, it gives you 2, so it would be the second degree for that one. If you look at this, a has an understood 1, b has 2. Exponent of 1 plus an exponent of 2 gets you 3. It's to the third degree for that one. And then this one, a, b again, 1 and 1 gives you the second degree. Now, they're also going to throw crazy things at you like this, and they're going to ask you, so this is a trinomial right here, and they're going to ask you what degree is that? And you're going to be like, well, if I add, it's 3 terms here, so what this term right here has 2, so it's a second degree. C only has an understood 1, that's a first degree, and 5 has a 1 as well, so that's a first degree. What degree does this trinomial have, or what's the degree of the trinomial? And you're not going to add them together. Only if it's one term are you going to add together. What you're going to do here is you're going to take the highest one. Just take the highest one. You have a second, a first, and a first, so what degree is it? Take the highest one, it's second degree for that. You're not going to add them together if it's more than one term. If it's just one term like this, yes, it's a second degree. Again, one term, third degree. But when it's taking 2, 3, 4, how many terms, take the highest degree of a term, and that is what that term is. So, confusing information maybe. I'm going to pause it again and jump to some examples and the practice set here to hopefully make sense of that. Okay, back at it. So all that information that I just told you, we're going to look at this and I'm going to see if you can see how that corresponds with problems then actually. So example 4, what they're asking is they want you to name the degree of each one. So how do you figure out degrees again? The way you figure out degrees is you look at the highest degree of any term. Don't add them together, just pick the highest one, and that's a degree. So you have an exponent of 3 here, exponent of 2, exponent of 1, exponent of 1. What's the highest degree of that term? 3, 2, or 1? Obviously it's 3, so that is what? It's the 3rd degree, is what you would write. That term has a degree, has a 3rd degree. B there, what is the highest degree of any term? You have 2, second term. 1, first term, 1, first term. The highest is second, has a 2nd degree. And the last one has a 1, and a 1. 3 separate terms, they all have 1. So it is the 1st degree for that. So it's 3rd, 2nd, and 1st degree for that. Again, it's weird information, but it's not complicated to figure it out. Then example 5 tells you to arrange the terms in descending order. So you take the highest degree and go down through to the lowest degree. So what is your highest degree here? You look at the exponents. You're just going to pretty much go from highest degree to lowest. The highest exponent, you have a 1 here, you have a 3, you have a understood 1, and you have a 2. So obviously 3 is going to be highest. So write that first. 2x cubed takes care of that one right there. What's left? The next highest is a 2 here. And that you take the positive sign with that. So plus x squared. Then what do you have left? You have x to the first and 2. You always put the number with these polynomials last because you're dealing with a bunch of variables and the number kind of is, the number's complete already. If somebody tells you I have 2 of this one, you have 2. But if somebody tells you I have x squared of this, you don't know what that is. So the number's always going to go last. So you put an x. Is the x positive or negative? Well, there's no negative sign, so it's understood to be positive plus x, and then plus 2. So arranging it in descending order, starting with highest going lowest, you have 2x cubed plus x squared plus x plus 2. Going to get you to do that a couple times. Example 6. This is where we combine the 2 things that we learned, adding mixed measures and the polynomial. You have x plus 6, and you're supposed to add 2x minus 3. So let's just write this in a better way. X plus 6, cross that out. You're just adding 2x minus 3. Here's a question, or not a question, it's a statement. A 6 and a negative 3, those are numbers. You add them on a daily basis. You can do that. So 6 plus negative 3 means 6 minus 3. So it comes down to. And so you have 6 minus 3 is 3. Now, you have x and you have 2x. This is often where you guys get stuck and you're adding them together. You're not multiplying, so you're not changing the exponent. You're just adding. What you're doing is you have an understood 1 from this x. 1x plus 2x's gives you 3x. This is a positive 3. So when you add these together, you get 3x plus 3. 2 terms, you're adding them together, give an answer of 3x plus 3. All right, jumping to the practice set. Then we run through these here. So for g, h, and I, you're supposed to describe it as a monomial, a binomial, or a trinomial, and name its degree. So in other words, how many terms does it have? And because that's where monomial, binomial, and trinomial, 1, 2, and 3 terms, and name its degree. So what is this? Well, you have, look for your positive and negative signs, because that often indicates. So you have x squared here, and you also have a negative 25. So there's how many terms? 2. So that makes it a binomial. What's the highest degree? it's a binomial, and you have a 2 and understood 1 here. So that means that it has a second degree. It's a binomial to a second degree binomial. H here, how many terms do you have? Well, you have the first one, then you have another positive sign and another one. So how many terms? 3. It is a trinomial. That's the name of it. What is the highest degree? It's the 2 here, so it's second again. Trinomial, second degree. Last one, how many terms do you have? You have 2x, positive 3y, and a negative 4. How many terms? 3. Trinomial. What's the highest degree? You have a 1 here, a 1 here, and a 1. So it's a trinomial to the first degree there. Right? Just figure that out. So that's the names of it. It's a binomial second degree, trinomial second degree, trinomial first degree. Letter J is arranging the terms in descending order, like we just did on this one over here. So pick the highest exponents, the highest degree. You have this right here. So we're going to pull that out. Positive x to the third, if it's the first number, it's understood. So we get rid of that thing. What's the next highest one? It is exponent of 2, negative 4x squared. Next thing is you have a number and a number with a variable. Variables go first, so negative 6x, and then what is that? It's a positive 5. That is how you arrange it in descending order. Now, for k, you're adding the trinomials. You're adding the trinomials together. So you just line this up, x plus x minus y plus 4. Again, the first part of this lesson was adding mixed measures. Here you go. Negative 2 plus positive 4. So negative 2 plus 4 gives you what? 2. Right? So it's a positive 2. If you have a positive 1y and you're subtracting 1y, what's left? 0y or nothing, because 0 times y is nothing. So forget about that. That actually disappears because you have nothing. So why would you can put nothing here, but why would you do that? Then you have, this is not a negative sign, say dash after the k. You have 1x and you're adding another x. So what do you have? 1x, another x, 2 x's. So the way that works out is 2x plus 2 for that one. And you, like I said before, you could put 0y there, but 0 times y is 0, so why would you put 0 in your answer? Doesn't change it, and it makes for extra work. So that is how you figure that out. Okay, understand it's a hard lesson. Hopefully you can make sense of it. Pause, rewind, play until you can figure it out. Let me know if you have questions.